Hello guys, my name is Isaac Flores and today I'll be discussing arrays and tracing code in this Explain It video. I'll begin by defining what an array is and then give an example of tracing code and the importance it plays in being able to write and understand the mechanics of a program, which is a fundamental to understanding what it's doing and when we need to also debug a code when something has gone wrong. So an array is a special variable that is able to store a list of items of various classes. As we have learned when working with images, two-dimensional arrays are essential in being able to access certain pixels in an image and to modify individual elements of an array to produce a desired effect. An analogy I like to use when working with arrays is a train, which represents the array as a whole, with each individual train wagon being represented by an element. Continuing with this analogy, in order to keep track of each individual element or train wagon, we must use an index to keep track of where that element is located within the array. An array index starts at 0 and represents element 1. This means that the index of an array runs from 0 to n minus 1, where n represents the number of elements within an array. So for example, I have created a 1000 by 1000 picture, which represents a two-dimensional array of pixel objects. So if I want to change half of the pixels in my picture to black in a diagonal manner, I must access each individual element, get the pixel, and set the color from white to black. So I'll run the program and see what we're doing. So we see that this program has created a 1000 by 1000 pixel object, which is our picture, and we have managed to turn half of the pixels to black. So then in order to accomplish this task that I just performed, I must understand and be able to predict how my program works so that I may give it precise instructions on which pixels to actually change. We can do this by tracing our code, which is really a walkthrough line by line that helps us understand what exactly our program is doing. So again, our program turned half of the pixels black. So as we walk through our program, we see that I've created again the picture object that is 1000 by 1000, that I've used a set of nested loops to be able to access all of the columns, which is our first or code line 16, and all of the rows, which is code line 18. And we see that our index starts at I equals 0, and it'll expand all of the width of our picture, and and our rows will be run through by the J index and goes from 0, which is this corner, to all the way to the length of this picture element. Now I put an if statement here where if J is greater than I, then we're gonna get the pixel at that position IJ. We're gonna set the color to black. So perhaps a better way to trace our code is to actually either write it down or use maybe an Excel document such as this one to be able to see what our code is doing. So we see that this nested loops will go through every single element on the I index, going through every single column, and then the J index will go through every single row. And then this if statement is what will set our pixel to black when I is greater than J. So as we move through our code, we see that 0, 0, for example, that pixel would be turned to black. but we see that I is not greater than j here, and all of this row I is not greater than j, so it will not turn that, it will not change that pixel to black. But then in this second row, j is greater than I, 1 is greater than 0, and so it will turn that that pixel into a black, and so it'll work itself in this manner all through this picture object that is 1000 by 1000. As you can see, this is where we appreciate the beauty of using nested loops to accomplish this task. So perhaps a better example, or an easier example to understand when tracing code, is another program that I have written here. And we see that as we work down our way down through this program, I've created an array of string objects. The array name is winners, and its first element contains Rob, Bob, second element Tom, and John, and so on. Now say that there is a race and they came in the opposite. John came in first, Tom second, Bob third, and Rob fourth. So I've created a new array of string objects named new winners, and what I want to do is to actually change the order of our winner array. How do we do this? We can use a for loop to index from I equals 0 to I less than the winner's length, which is 4, so it'll index from I equals 0 to 3. And we're going to be accessing, when I equals 0, we'll access element number 1 from the new winner array, but we'll set it equal to the winners array at its last element, I equals, our winners, at I equals 3, which is the last element. Perhaps, and as we loop through this, we're going to see that we're able to change the order just as we wanted it to. So perhaps a visual representation like this does a better job at explaining what is going on. So we see that our array, our winners array, has an index from 0 to 3 with 4 elements, and at each element is a name or a string object associated with it. Our new array that was created has null associated with it. This shouldn't really be 0, it should be null, because there's no names that were associated with each element. So as we loop through our program at I equals 0, we see that our program will access the first element on the new winners array, but we'll set it to the last element on the winners array. So for I equals 1, we see that we access element number 2 on our new array, on our new winners array, but we're going to set it to our winners array index number 2, and that will equal Tom. And then when I equals 2, we access index number 2 in our new winners array, but actually set it to index number 1 on our winners array. And we can move on that way and actually change the order just as we had desired, and then we can actually print out to see if our program produces the desired result. And we see here that in our last part of the program, we have looped through each individual element to print out to print out each element, and we see that our new winners array says John, Tom, Bob, and Rob, which is the opposite of our winners array. Alright guys, that's all from me. Thank you for listening. Have a good one.